Welcome to Observation, so the program that considers the things of God and compares them to the ideas of man. In this regard, it's my pleasure to welcome one of the most informed individuals I've had the pleasure of getting to know. His name is Roy Goodman. He lives in the land down under. Roy is a scientist, and for those who may not be familiar with Roy's name, is part of the series of programs. Roy and I did a program on dimensions, which was one of the most listened to, one of my favorite in the history of both Shattering Myths and Yada Yada Radio, something that maybe we will have to delve into once again. But it's good to hear your voice, Roy. Welcome to Observations.
Thank you, Craig, and thank you, Scott. I'd like to start off with a bit of history, if I may.
Please.
In 1860, in Oxford's Natural History Museum, a famous debate between Thomas Huxley, otherwise known as Darwin's bulldog, and Bishop Samuel Wilberforce occurred. This debate is considered a pivotal historic moment when science supposedly defeated religion on the question of the origin of all life and the laws governing human behaviour. Now with this, after this debate, mankind could formulate his own laws and live in freedom from a harsh and unforgiving God, or so they thought.
Yeah, let's just pause there just a moment, Roy. That's where a place where I wanted to begin, because this debate was between a fellow who chose to extrapolate far beyond what Darwin had observed and written. And his name was Thomas Huxley. He is the founder of the religion of man. Socialist secular humanism, humanism as a religion, is actually formulated by this individual. So what we have is the religion of man pitted against not God, but against religion. It was really a competition on that debate between two religions, was it not?
That's correct. I have to say that Huxley was not really the progenitor of it. I mean, that sort of idea had been going on for, what, hundreds or if not thousands of years beforehand. I mean, God has never been really popular.
Well, it's true. There's always been ideas that elevating man to the status of God. As a matter of fact, virtually every pagan religion depicts gods in the image of man. That's why all the statues of false gods throughout history are always done in a man-like or woman-like form, and we've always projected our characteristics on our gods. It's just that Huxley is the Humanist Manifesto is a product of Huxley. He codified what others had been brewing and developing for some time. But the thing that most people don't recognize that's essential about this particular chasm in human history, this fulcrum of human history, is that what Huxley had to say on behalf of his extrapolations of Darwin, much of what he had to say has subsequently either proven to be untrue or misinformed, and the foe he was debating against was essentially Roman Catholicism as opposed to Yahweh's testimony in Bereshith's Genesis.
Correct. Yes, that's right. But of course they didn't know very much about what was in the cells, or in our cells at that time. In fact, they thought it was just simply a piece of gelatin-like material with a membrane around the outside. And had they known what we now know, I don't think Huxley would have got off the ground in the debate. He would have just been destroyed.
If we knew,
Wilberforce didn't know that, and even though even if Wilberforce had known that, it still remains a debate between two corrupt religions.
Yeah, if it had been a scientific debate on the spontaneous generation of life without any outside influence and its onward and upward migration ever since that moment, based between two informed scientists, Huxley would have been rendered such a fool, no one would have ever heard of this debate.
That's right, yes, exactly.
Yeah. It's almost always the case that science argues on behalf of what it thinks to be true or believes to be true at the moment, only to find out that almost none of it is true. For example, when that debate took place, 90% of scientists, maybe more, believed in a thing called the steady-state universe, that the universe was the constant I am, that it had always existed, and that it had never been created. The notion that the universe was created was anathema to them. Is that true?
Yes, that's completely true. In fact, a British cosmologist by the name of Fred Hoyle had proposed a concept called panspermia, which was based entirely upon the steady-state universe. The steady-state universe had the problem that they couldn't quantify the generation of new energy that was required to keep the universe steady state. Because obviously the universe, as they could see it, was winding down. The suns, for example, were burning up their fuel and dissipating the energy.
Right.
So where did new energy come from? That was a problem that they had. So they had to figure out a way, or tried to figure out a way of creating new energy, which is scientifically really quite dubious. It just didn't hang together. So
so then there was a discovery called the redshift that proved, and this was in the 20th century, that the redshift was discovered. In other words, approximately 100 years after this debate, that proved that the creation, that the universe was created, and that God, his name is Yahweh's proposition that the universe was created and had a beginning was in fact true, and that science was entirely wrong.
Well, science was wrong insofar as the hypotheses were at that time, yes.
Yeah, the steady-state universe was an entirely errant proposition.
Yeah, the steady state, but not all science, of course, is wrong. It's just that the hypotheses that have been made concerning the universe were then wrong. That's true.
Yeah, the topic we're discussing is the topic that they discussed in a large degree, which is did the universe always exist, or was it created? And science held that the universe had always existed. They were shown to be wrong by Hubble.
Correct. Absolutely correct.
And that the redshift was the phenomenon that proved beyond any doubt that the universe was expanding, and the fact that it's expanding, you extrapolate backwards, it had to have a beginning.
Yes, that's right. It was expanding because of the redshift. What that means is that due to the Doppler shift, I don't know whether people are familiar with this. Doppler shift simply means that there's a change in the frequency, whether something's moving away from you or towards you. Yeah. Now, if something's moving away from you and it's emitting a signal that's coming towards you, the wavelength of that signal gets stretched. It gets longer and longer. Now, the lower end of the energy range or the frequency range is red. The higher energy of the frequency range is blue. So that means if something's moving towards you, or even parallel to you, such as the Andromeda Nebula, which is moving more or less parallel to us, it's the only one that has a slight blue shift towards us. All the other galaxies have a redshift, and in fact the redshift gets very much bigger the further away they are. So they're not only just simply moving away at the constant speed, they're actually accelerating away from us.
Yes.
And that redshift was then used to, or conceptually, if the redshift is occurring and you look in every direction, you see everything moving away from you. And if you run the camera backwards, then everything will come towards you and eventually end up in a point which we call a singularity, or what's now known as the Big Bang. That is, it came out of nowhere, or seemed to come out of nowhere.
So when Hubble came up with this realization, and then they ran the tape backwards, if you will, in their minds, and they were correct to do so. Redshift and the Doppler shift is a reality; it's not a theory.
Correct.
Then and they came up with this idea that, okay, so the universe we now know was created But they didn't still want to acknowledge that Yahweh, the author of the Torah, was correct. So they entitled the creative event the Big Bang. But didn't God use exactly that same phrase to describe the creation of the universe?
He did, in Bereshit.
Yes. 3,500 years before man would apply the same term. As a matter of fact, if we roll back I know we want to talk mostly about evolution here, but just thinking a moment about the creative event, all we're able to measure from this Big Bang is quark confinement, the point where energy can coalesce into matter. Prior to that time does not flow or move in a way that we can calibrate it as we do now.
That's right, but it moves very slowly. The higher you go in mass, the more slowly the relatively, that is to us. In other words, if you're looking at someone from a distance who is very massive, the time that person the person's clocks will have is slower than the clocks that we have. That is to say that to us they appear to be sort of moving along at a snail's pace. So the further, the more massive you become, and that implies going up in dimensions as well, then the slower and slower time becomes. But this is only a hypothesis on my part, I can't prove it, but I suspect that time never actually stands still completely. But there's always some degree of movement. Say, for example, in Yah's dimension, whatever that may be, we postulate at the moment that it's the seventh dimension. His time, in fact, to him, may be quite normal. He's doing his things and everything's moving along quite nicely. But if we were somehow able to see him, then he would appear to be us to be completely stationary. Whereas, on the other hand, when he was looking at us, it would be zipping past at enormous speed. This is why you can have, for example, 6 days of creation from his point of view. So he looks forward in time and sees our existence going past at an enormous speed, whereas we can look back over a period of 14 billion years approximately to see the same events occurring in our time frame.
As a matter of fact, we can actually measure the difference in the speed that time moves relative to the creative event based upon the stretching of the wavelengths in the cosmic microwave radiation that's left over from that Big Bang event.
That's correct, yes. And that was done by a fellow called, what was his name now? Schroeder.
Yes, Schroeder was the first to apply the math to it, but the analysis of the stretching of the wavelength based upon what occurred during the Big Bang, the Wilkinson probe and many others have consistently been able to calibrate the stretching of the slowing of time at the creative event. It's approximately 10 to the 12th power, is it not?
Roughly that, and the way that they got that was that when the Big Bang occurred, it was extremely hot, unimaginably hot. As it cooled, you found these things called quarks appeared, which weren't things that we're familiar with in our terrestrial existence. But they, as the temperature further cooled, they got to a point where they coalesced together, according to the laws of physics, which then applied, to form the basic building blocks of our matter, such as neutrons and electrons and protons. This was called quark confinement. It wasn't actually an event well defined in time. That is to say, there's sort of a bit of a variation in time as to when it actually occurred. And this is one of the reasons why the Hubble estimate, for example, of 13.7 billion years may be out by a little bit.
Yeah, as a matter of fact, it appears that it's off for a number of reasons. We did a whole program on the 3 different means of evaluating that particular time.
That's right.
But there are now discoveries of distant stars and galaxies that suggest that the universe is older than their 13.7 billion estimate. The most likely number when you evaluate the various options that are available to us on quark confinement is just shy of 15 billion years, isn't it? Just a little over a billion years longer than is the most popularly promoted theory at this point.
That's right. No one can be really certain of the exact figure there. That's the thing.
Yeah.
One thing we can be certain of is the background temperature of space, and that's what gives you the 10 to the 12 power, or approximately 10 to the 12. It's not exactly that, but it's close enough. So the difference between the temperature at quark confinement and the temperature of free space now, which is 2.73 degrees absolute. People who don't know what absolute means is that if you keep going backwards in temperature, it gets colder and colder, obviously, but you get to a point where it's called absolute zero, and that in our centigrade scale is minus 273 point, a few little decimal places as well. The interesting thing is that you can't get to that temperature. As you get closer and closer to it, it becomes what's called asymptotic. That is to say that the efforts to get there sort of move you along a line that's approaching absolute zero, but it's like a black hole. You can never quite get to the singularity, which in this case is absolute zero. But it's approximately 273 degrees below zero in the centigrade scale, which makes it pretty damn cold. So at 2.73 degrees, that's where the residual microwaves have stretched to. Now, a microwave is just another form of electromagnetic radiation. It's been all stretched out. It comes from the same thing I was talking to you before about the Doppler shift, but it's not the same scientifically as the Doppler shift. It's due to the space itself stretching, and as it stretches, the wavelength stretches as well. So it starts off as gamma rays, which are extremely high energy electromagnetic radiation, out right at the other end of the scale. And as space stretched, it stretched out to be 2.73 degrees absolute, or very, very long wavelength microwave radiation. So the difference between those two temperatures, or the difference between the wavelengths, if you like, gives you that figure of approximately 10 to the 12. That's where that all came from.
And if you divide the most likely estimate of the universe's longevity from the point of the Big Bang, multiply that billions of years times days in a year, and divide that by 10 to the 12.
You come to a number it's an approximate number, because we have only an approximate estimate of both quark confinement and the age of the universe. So but that approximate number is pretty damn close to 6. And in fact, when I first saw that, that made me sit up, because I was before that at least an agnostic.
Yeah.
And as soon as I saw that, I said, hello, what's going on here? How could Moshe have known that number? Of all the possible numbers you could choose, he just happened to choose the right one. Is he very good at gold lotto, or what? You know?
Yeah, that was the realization that where I transitioned from a faith-based creature that was curious as to whether or not God existed and he could be known, to an individual who knew, was absolutely confident that the author of the Torah had proven his existence. And there's really no possibility that you would come to that number by chance. Now let's transition, if we could, from the age of the universe, because the age of the universe actually has a lot to do with the discussion on evolution. I remember a series of Scientific American articles that the basic theme was, it's improbable that life could have emerged from random chance. But given enough time, the improbable moves all the way to probable. And the numbers on improbable are mind-boggling, and we'll consider those in a moment. And what they were talking about is that they thought that they could play this game over the 4.8 billion years that the Earth had existed. But they really didn't have that much time, did they?
No, they certainly didn't. I'll have to disagree with the age of the Earth. I think it's 4.5 billion, but I mean, that's just a quibble.
Okay.
After the Earth had formed in the primordial disk, again, there's sort of a bit of a backtrack here, a gas and dust cloud collapsed to form the Sun and the planets.
Right.
And as that was called an accretion disk, that is to say that everything was being accreted, if you like, by gravity into the centre. Something had disturbed that gas cloud to cause it to start to collapse. Once it started to collapse, then it had to continue, because it was just simply falling down a gravitational well, if you like. And the Sun formed, the planets then formed around it. The mechanics of it is really quite mathematically interesting.
Let's speak a moment there, because what we're talking about here is a universe that is between 14 and 15 billion years old in all likelihood, but an Earth that is just 4.5 billion years old. One of the things that's really interesting about all of this is that our Sun and the Earth have to be the derivative of a collapsed star, don't they? Aren't we, at the very least, a second generation star and solar system?
Well, yes. First of all, the Earth has to be the same age as the Sun, obviously. I mean, it came from the same accretion disk. So that means that all the dust and gas that was in that accretion, or in that cloud, the primordial cloud, had to contain heavy elements that have come from supernova explosions. Now, can I backtrack here a minute? The nuclear reactions that occur inside stars is quite interesting. It starts off with hydrogen, which burns, and when it burns, it turns into helium. And then you've got a shell of helium around that core of hydrogen, if you like, that's burning, and that turns into the next heavier elements and so on. And that process gives off energy up until you get to the point of iron. Now, after iron, you can't form the heavier elements by nuclear fusion. So what has to happen to produce that is a gigantic explosion called a supernova. Now, the very, very heavy stars, and our Sun won't end like this, but once you get above about 4 solar masses, when the stars, because the stars are burning their fuel much faster, the heavier they get, they burn them faster. They ultimately come to the point of the iron catastrophe. That is to say that they can't continue to burn the nuclear fuel to oppose the gravitational collapse of the star. So what then happens is that the nuclear reactions stop, the pressure caused by the burning against gravity stops, the star then collapses in upon itself and turns into an extremely dense core. If it's a certain mass, it will go into what's called a neutron star, and the neutron star will then, the infalling material hitting that mass has so much energy that when it hits it, it forms the heavier nuclei and then rebounds, if you like, off into space. So now you've got space scattered with all of these things like gold and silver and platinum and whatever. The really interesting thing is, I mentioned Fred Hoyle before. He came up with he was really quite bright. He came up with a notion as to how carbon was formed. And since we need carbon to make our forms of life, that is a vital nuclear reaction, but it's a very curious one, because it's based upon 2 helium nuclei and 1 beryllium nucleus. Now, beryllium is the fourth. It goes hydrogen, helium, lithium, beryllium. That's the fourth atom on the periodic table. So it requires 2 helium nuclei and a beryllium nucleus to come together to form carbon. But it doesn't work unless the beryllium is in an excited state. And Hoyle worked out that the probability of this occurring is extremely small. So the fact that we've got so much carbon around is a very curious phenomenon. It's as if it's been as he would say, monkeyed with to produce what was required. And in fact, if I may quote...
But and what he means by monkeyed with is that if you just run probabilities based upon the laws of physics, you just don't get there.
That's right, yes.
There had to be an outside influence. But go ahead, read what he had to say.
He said, would you not say to yourself, some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule. A common-sense interpretation of the facts suggests that a super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me to be so overwhelming as to put this conclusion almost beyond question. And another part that he quoted is, if one...
Well, that is profound. I mean, with the exception of the terminology, we don't very much like to view God in the monkeyed with terminology, and I'm sure he chose monkeyed with just to come off credible after he was saying, in essence, a superior intellect designed it and then acted upon it. If he had said superior intellect designed it and acted upon it, he would have been discredited, but if he used the term monkeyed with, then he's at least going to be considered in that community.
True, but he did in fact say, and if I can continue with another quote, if one proceeds directly and straightforwardly in this matter, I don't know what he was referring to there, but without being deflected by a fear of incurring the wrath of scientific opinion, one arrives at the conclusion that biomaterials with their amazing measure of order must be the outcome of intelligent design.
Yes,
and that was Fred Hoyle, Evolution from Space. Now, of course, he was at least an agnostic, if not an atheist, so of course he was pushing the panspermia idea, which we'll come to later.
Yeah, so that's fairly amazing. By the way, I would ask you, what numbers associated with man, and what day, according to Yahweh, and the progress of the evolving nature of the creation of the universe and in the authorship of life, what day was man conceived?
6.
What is the atomic weight of carbon?
The atomic number?
The atomic number of carbon.
Yes, 6.
Yeah, and we are a carbon-based life form. Just an interesting coincidence, I'm sure. All right, so the reality is that even though the Earth may be 4.5 billion years old, you don't get the beginning of that time as to count in terms of your enormous chasms and eons of time for life to evolve, because the conditions didn't exist on Earth for a considerable period of time for life to be manifest. Isn't that correct?
That's right. If the Earth was 4.5 billion years old, again, as the accretion disk formed, all the matter that wasn't formed into planets was then sucked in by the gravitational pull of both the Sun and the planets. So there was this enormous cometary bombardment, not just of the Earth, but of all the planets, until, of course, all this material was swept away. So now we just have the more or less clear space around us that we have. So these infalling comets had energy, and that energy, when it hit the Earth, was dissipated in the form of heat. In fact, there was so much heat around that the Earth's original crust, that is before the bombardment, was melted.
Yes.
It obviously couldn't support life. So until the cometary bombardment finished, then you had the problem of until the cometary bombardment finished, nothing could happen. So when it cooled, after the cometary bombardment had formed, and water could then exist as water in pools and oceans and things like that on the Earth, then and only then could life form. And in fact, it was demonstrated by a scientist called Professor Bargehorn that microfossils of a very ancient form of bacteria called a cyanobacterium were found in rocks in gneiss, that's G-N-E-I-S-S. That's a form of rock in Greenland.
Yes.
In what are called stromatolites. Now, stromatolites, in actual fact, still exist. And if you go to Shark Bay in my country, that is Western Australia, you can actually see what they look like. They're sort of like mushrooms sticking up, and they're full of bacterial colonies. Now, the significance of the bacterial colonies is that these particular things, a bit like green algae that you find in a pond. You go and have a look at algae in a pond and put it into sunlight, and you'll see bubbles starting to form. And those bubbles are oxygen.
Yes.
Now, the early Earth's atmosphere was thought to be reducing. That means to say that it didn't have any or little oxygen. It had all sorts of poisonous gases, from carbon dioxide to methane, to oxides of sulfur, oxides of nitrogen, even cyanides, for example, and it certainly wouldn't have lasted very long if you'd been on the Earth in those days. So what
you would have corroded.
Yeah, literally.
Yeah, literally.
In fact, our atmosphere probably would have looked a bit like Venus does today.
Roy, we're going to hold you on that point right there, and we'll be back with observations in just a moment. Welcome back to Observations. We're having a discussion with Roy Goodman about both the Big Bang, the creative event that began the universe, and its consistency with Yahweh's instructions, and its inconsistency with science at the time that it was developed, and have moved to macroevolution and the likelihood that macroevolution is a valid idea. The first issue, of course, was that the idea of the extraordinarily improbable, and we'll consider how improbable it is in a moment, became probable with the passage of billions upon billions upon billions of years. But what we're discussing now is that time did not exist for life to be conceived, and that Roy, you were discussing this period about I guess say 3.8 billion years ago, about 700 billion years after the Earth was conceived, that we actually had liquid water, and how soon after that we had bacterium that was producing oxygen and cleansing our atmosphere of what was very caustic chemicals at the time.
That's correct. First of all, I should think that for those who don't understand what the terms are, macroevolution is simply called abiogenesis, or, if you like, spontaneous generation of life from nothing. That's an important concept, I think. The bacteria developed very soon after the cometary bombardment finished, around about 3.8 billion years, or maybe even sooner than that, because Bargehorn, of course, may not have got the earliest rocks. At any rate, that would have given him something no more than 400 million years in which to develop life. Now, we can demonstrate further on that that is just way too short a period of time, just a blink in the geological past. And for life to have developed in all its complexity in that short period of time is impossible. And once it'd been placed there by Yah developed the bacteria, he developed the genetic code that goes with it, and he set it away. And he's not a hands-on kind of guy. He set it running and, if you like, sat back to see how things went. Now, over the next 3 billion or so years, those
by the way, for those who think that's callous, it's the way it ought to be. And it's really the way it ought to be, is because if he didn't do it that way, if he micromanaged everything along the way, there's nothing to enjoy, there's nothing to see play out, there's nothing to learn, there's nothing to experience. If you're micromanaging and manipulating everything, it's so much more exciting to come up with a formula that has the potential to deliver all of these marvelous things and then enjoy the process.
That's right, and in fact, Yah developed the universe and, of course, our life to be indeterminate from the beginning.
Correct.
He knows what the end is, because in his past he can see our future.
Yes.
But he decided that he would allow us to have free will, and this is a bit of a sidetrack. To give us free will, the universe had to be indeterminate, because if it was a clockwork universe such as Newton suggested, then everything by definition is predetermined and there is no free will. So that the form that we find the universe in is what you would expect of a God who provides us with free will. Anyway, back to the cyanobacteria. They fixed these poisonous gases in the atmosphere, turned them into chemistry in their own bodies, if you like, over billions of years, or within their own cells, should I say, over billions of years, and cleared the atmosphere, so that we now have an oxygen-nitrogen atmosphere that is transparent. And that transparency now enables us to see clearly the sun. Because if you were standing somehow back on the Earth at the time that cyanobacteria were created, you would have been aware of light, but you wouldn't have been able to see where it was coming from.
Can I interrupt you here? Can I interrupt you here? Because there's just a profound tie-in here with the Ba-Rishit, better known as Genesis account. Because the atheist will say that it isn't credible, and their primary argument against the creative account, saying it's not credible, is that animal life was bacteria, if you will, plant life, not animal life. Plant life was conceived by Yahweh and developed over the third day, where it says, then on the fourth day, the sun and the moon became visible as signs. They have to be signs for the meetings that Yahweh had established. But that's exactly the way it occurred, isn't it? That this form of animal life, of plant life, if you will, existed before the Earth's atmosphere was transparent.
Yes, that's right. But it was also the day, if you like, was a metaphor for the period or the time that was needed to clear the atmosphere. Once you could clear the atmosphere, then you can see the sun and you can see the moon.
Right.
And that will give you the signs.
Precisely in the order that it actually occurred, making a mockery of the argument against creation. I remember when I was writing my books on Islam, and I was trying to read up on what others had said. Almost everybody, to be even-handed, tried to discredit the creation account in the Torah by saying that it's stupid to say that the sun was created a day after plant life. But in fact, what it says is that the sun and the moon became visible, and in fact, that is the way it occurred. That plant life was conceived, and after plant life had an opportunity to flourish and to consume these, in many cases, these toxic materials, and as a byproduct deliver oxygen into the atmosphere. The atmosphere became transparent.
That's exactly right. And when it was transparent, it was now time to start a new creation. And this is one of the times, I think, when Yah did intervene. I mean, it is certainly possible that he front-loaded the DNA from the very beginning for this to occur, but I suspect because of the short period of time which all of the fire appeared, in fact, he made the creation.
And we should be careful by saying that it's one thing, you were correct in saying that God does not micromanage. But it does not mean that he's an absentee landlord either. He does at times, at specific times, by his own declaration and by historical affirmation, there are very specific times where he does intervene in a very real way. And I think you're correct. I think this is one of those times.
The Cambrian explosion occurred about 550 million years ago. There were some multicellular organisms called the Ediacaran fossils that occurred before then. They may in fact be actually joined in with the Cambrian explosion, but it occurred over a period of about 5 million years, which is really a geological blink in time. Now, if you actually then use the 6 days, 15 billion years analogy, you can actually work out that it would have taken, from Yah's perspective, 2.63 minutes to actually develop the entire life forms that we find on Earth here.
And that's every life form that we know today. I mean, it's the basics of every known life form all came into existence in what would have been, from his perspective, a couple of minutes.
That's right.
And from our perspective, looking back, about 5 million years.
That's right, yes.
But that 5 million years, or to go from essentially a plant to go to every type of animal in a 5 million year period completely undermines the time, solves the improbability of spontaneous generation of life.
Well, yes, I can go on to that if you like. I produced a protein when I was working in the laboratory. It was called apolipoprotein C1. Mm-hmm. It had just 57 amino acids in it. Now, amino acid is one of the basic building blocks of all proteins. Mm-hmm. There's more than 20, but we use 20 to build humans and most animals, in fact. Now, there are more unusual versions, but we can sort of ignore those. So you've got 20 amino acids that you require to build that 57 amino acid.
Now, by the way, that protein, how did you go about building that protein? Because you didn't build it from scratch. You're a smart guy, but you aren't quite that, and you're creative, but you aren't quite that creative. Why don't you share how you went about developing and creating this protein, which you called C1?
Okay, we'll call it C1 for short. To build a protein, generally speaking, you require a bacterium or a virus of some kind. Usually it's a bacterium, and one that's relatively safe to use. And the safest one is a thing called E. coli, which as the name suggests, you find in your gut. The E. coli will have a circular piece of DNA in it that we don't have, and it's called a plasmid. And the plasmid has got various genes on it. There's a switch to start things being transcribed and read. And what you can do is open that plasmid up. First of all, what you do is you destroy the organisms, separate out the plasmids, open the plasmid up, insert a DNA sequence that you have yourself made, and you can do that. It's only a very short sequence. So you can then insert that into the plasmid, then put the plasmid back into the cell. It's usually due to a process called electrophoresis. Then it goes back into the cell. Then you grow up the E. coli in a broth, and so that there's billions and billions of them, and now you've got billions of copies of your DNA, which the bacterium then expresses to form your protein. So that, in a nutshell, is how that was done. And then you break open the cells, and then you use special columns to separate out the protein that's yours, because there's a special thing like a bit of Velcro, if you like, that recognises your protein only and discards all the others, and it sticks that protein on, and that purifies it so that now you've got your protein and you can identify it. So even with intelligent input, in some way dispute the intelligence, but if you're with intelligent input, you can in fact do that sort of thing.
But you began with life.
I began with life.
You began with life in creating your protein. And your protein was relatively simple. I use that with tongue-in-cheek. It had 57 amino acids in sequence, correct?
Correct, yes. But the sequence is important as well. And from the point of view of the functionality, a protein, generally speaking, has a primary sequence. It has a secondary structure and a tertiary structure. Now, in the case of ApoC1, it didn't have a tertiary structure because it was so small. But your average protein will have a sequence that is very specific. You know, amino acid type 1 will go here, amino acid type 2 there, and so forth, all the way along the length. And the type of amino acid and the sequence of them tells the protein then how to fold thermodynamically into its lowest energy state. That means to say that it can then fold reliably, if you like. It likes to be in that position, so it's thermodynamically at the lowest point. So what it does is it folds into what are called helices, or alpha helices, and beta pleated sheets and other things, and then when that's happened, then the whole thing folds into another form called the tertiary structure, which is usually the functional structure. For example, an enzyme may have, by that folding process, brought certain amino acids together into a cleft that enables the enzyme to work on two molecules, for example, to either bring them together or break them apart. The way that that's done, I won't go into the detail of it, but it's a very complex process, obviously, in doing so. But if you get the sequence of the protein wrong, you won't get the right folding, and if you don't get the right folding, the resultant protein is useless. It doesn't work.
So just take your simple protein. For example, in our biology, we have 20 different amino acids. Most animal life is 20 different amino acids, and you just had 57 very, very simple protein. What are the odds, by chance, by random, that you would get those 20 proteins to assimilate in the proper order?
10 to the 57 it works out to be, but that's one chance in 10 to the 57. But can I backtrack a bit here?
Sure.
Because a lot of people don't understand what macroevolution is really telling us. Macroevolution says that on the Earth, early on, there was all of these organic molecules falling from the sky. Now, they were falling from the sky because a fellow called Miller actually did an experiment in which he put what he thought was the original gases of the Earth into a reaction chamber, sparked them with an electric spark, and after a couple of weeks they found a sort of brown sludge on the bottom of it, which when analysed turned out to be amino acids. Now that means that these amino acids in fact could have formed in that way in the Earth's primordial atmosphere. So, you know, open the champagne bottles, we've proved one part of abiogenesis.
Yeah, but is an amino acid life?
No, of course not. No. What it really means is that these things just form readily if you have the right circumstances. In the same way that iron will rust if you put water and oxygen together with it.
Right.
I mean, it just simply does it. So these things will automatically appear as a lot of other building blocks of life can be shown to appear as well. So that experiment means that they were saying, okay, now there's all these amino acids falling into pools of water, and they're sort of floating around there all by themselves. Now, the next thing is that just by happenstance, for example, a lightning bolt may come along and it hits a tryptophan molecule, which is one of the forms of amino acid, and it energizes it so that it then attaches itself to a phenylalanine and so on. So you get in other words, to get the sequence, it goes 1, 2, 3, 4, 5, 6, up to 57, all joined up by these random processes.
It was pretty amazing. So not only we'll acknowledge the fact that that once you have a second generation construct from a supernova explosion, and you have the elements available, and then you have the environment on Earth that evolved from that you will have amino acids. You would then need to have some force nudge them together, and not only get them to form together, but these different amino acids would have to be nudged somehow, lightning bolts, I guess, just striking without destroying them and putting them in proximity together in a very specific order.
That's right. The specific order would be, you have to have, for example, I think I've used in my example, what did I use? Serine, I think, well, we'll call it, well, it doesn't really matter. Amino acid one might be a serine. Okay, so you've got 1 in 20 ways you can pick serine out of a pool full of the 20 amino acids. So that's the first position you've got to fill. The second position might be a threonine, for example. Okay, so you've got another 20 ways of choosing that, and so on, all the way up to the 57. Now, the way that probability works is if you use the word and, for example, so you've got to have 1 and 2 and 3, then the chances of getting that one is going to be 1 divided by 20 by 20 by 20, all the way up to 57.
Right.
And that works out, if you do the maths, is 1 chance in 10 to the 74. That means it's 10 multiplied by itself 74 times.
You know, we as humans have a very difficult time with big numbers. and that is a rather stunning kind of a number. I mean, is there anything that you can share with our listeners that would help them understand what 1 in 10 to the 74th power of creating an extraordinarily simple protein would be?
Yes. The number of particles in the known universe is roughly of the same order, same magnitude. Roughly the same magnitude. So the whole of the universe has particles in it, which is roughly 10 to the 70, some 10 to the 80, something like that. That's the same probability as making even a small protein like that one. Now, if you go ahead and make a bigger protein, can you imagine the numbers involved? In fact, Fred Hoyle himself, if you like, kicked his own goal. He said there was a 1 in 10 to the 40,000th chance of making even the simplest bacterium. It was his calculation. And this is from an eminent scientist of his era.
10 to the 40,000th power. I mean, it's
right.
just, this is so astonishing in terms of the number that it's hard to fathom. Listen, it's hard for us to fathom the number of stars in the universe, with 100 billion stars in the average galaxy and over 100 billion galaxies that we know of. And that only represents about 6% of the universe. We can't even fathom that. But then think of these enormous stars and solar systems, each comprised of particles, and we're talking about an astonishingly large number beyond the known particles in the universe. And by the way, with your simple protein, 10 to the 74th power, which is as many particles as there are in the entire known universe, roughly, that's just one very simple protein.
That's right.
It has no means to reproduce itself. It has no means. It has nothing to consume for food. It has no way to join with other proteins to create an animal life form. I mean, we are such a chasm at that point away.
Well, what's even worse is, of course, is that the same UV radiation and lightning bolts that allegedly formed it in the first place also work to break it down.
Right, almost immediately. Almost immediately.
That's right.
Yeah.
I mean, the only number that's bigger than 10 to the 74 in the universe is the U.S. national debt.
And even as we talk about trillions of dollars, a trillion is which it's a huge number.
It's 10 to the 12.
It's 10 to the 12.
That's right.
Right. And we're talking about here for a simple protein that gets you nowhere. I mean, it gets you nowhere because it's unrelated to anything else. It doesn't join with other proteins. It has no function. It can't reproduce. It can't grow. It can't do anything. Is 10 to the 74th, and to create a bacterium, I mean, a really, really simple form of life, according to Hoyle, was 10 to the 40,000th power.
Oh.
I mean, we're dealing with numbers that if you were to postulate a religion, which socialist secular humanism is formed on this postulate, and to say that I want you to believe that this unlikely event occurred, and it didn't occur once, it occurred many, 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 many times. And every time it occurred, it was victorious and lived and reproduced and then became more complex and thrived. What do you think the odds are that you could fool a world of people that something that 10 to the 40,000th power took place?
I think, unfortunately, it's fairly easy to fool most people because they have no concept of what these numbers mean.
Yeah, I guess so. I think a lot of it, Roy, is something we've talked about in the past. And that's why, and I want you to, there's other issues here that we need to discuss, but one of the biggest challenges that we have when we talk about the fact that 10 to the 40,000th power for a very simple form of life, a bacterium, is improbable to the point of being laughably impossible to have occurred in the time that's available for it to occur, and the medium for it to occur, and then for it to go on beyond that, is that we have, over time, particularly with socialist secular humanism, we've dumbed people down to the point that they're not judgmental. They're not going to exercise good judgment regarding this information. And I think, Roy, that the basis of exercising good judgment really is probability. And if you pull probability out of people's thought processes, it becomes almost impossible for them to discern between truth and lies, between that which is possible and that which is not possible.
And the worst part about it is they don't want to know.
They don't want to know. Yeah, they don't want to process it.
Yes.
But we're dealing with probabilities, and probability is the mother's milk of reason.
Yeah, a few people will respond. I've had a few people respond positively, and they've come back and questioned me, but I think that they've probably then gone away and spoken to a quote, expert, unquote, and then fallen by the wayside after that.
Yeah.
Because the expert would have been a macroevolutionist, if you like, a socialist, secular humanist, and they have agendas.
Absolutely. They have to sell this vision of faith, because what they're trying to get people to buy into is flat out impossible. And not only is 10 to the 40,000th power impossible, you're still nowhere when you have the bacterium. You're just nowhere. Now, why don't we talk about the next challenges? Entropy, this tendency of things to go to disorder without outside input or direction. Because even if you've created that first bacterium, then what?
Well, that's right. But can I just backtrack again for a second?
Please.
A moment. That comes back to the macroevolutionist idea of self-organizing molecules. They do occur. Self-organizing molecules, the idea behind, of course, self-organizing molecules is, for example, you can then form the bilipid layer of a cell wall spontaneously. And indeed you can. I mean, it's just like a soap mycelium, for example. All those little cloudy things you can see when you put soap into water, just little fatty drips with charged sodium or potassium on the end pointing out to where the water is, and all the fatty bits are in the middle. So that self-organizes spontaneously into that. And in fact, that comes back to thermodynamics and the lowest energy potential. But you see, cell walls can form spontaneously, and that's what they say, okay, we've got self-organizing molecules now, why can't something like DNA and RNA and proteins self-organize? But of course, self-organizing molecules are inherently low information states. For example, if you have salt in water and you evaporate the water away, you get salt crystals. But the salt crystal is in the form of a lattice, as it's called. That means to say that each sodium chloride molecule is equidistant from every other one, and it forms the crystal. The thing is that each sodium chloride molecule is no different from everyone surrounding it, which means that if you want to take statistically, again, the way that you did my protein, you have to have one in the first position, a particular amino acid in the first position, a particular amino acid in the second, and so forth. With the self-organizing molecules, it doesn't matter which ones you take, because you end up with the same structure. So it's what's called a low information state, whereas the organic molecules, such as DNA and proteins, are very high information states. That is to say that the sequence of the thing is critically important. It's not just the fact that you've got these amino acids at millimade, you've got to have them in the right sequence to get the code correct, which then makes the thing work. Yes, sorry, if you want to continue on.
No, it's all beautifully stated that the examples that are used by the evangelicals for the apologists for macroevolution will always cite something that they know themselves doesn't hold water. They know that their argument of self-organizing molecules and structures fails when you simply explain that, yes, very simple lattice structures will form, but we're talking about organic molecules, and with organic molecules, they are very high information. The order of things is essential, where in the lattice, the order is irrelevant.
Correct. That's right.
And they know this, by the way, but they'll deliberately preclude that information when making their argument.
Now, the other thing, of course, that works against macroevolution is thermodynamics. The first law of thermodynamics is essentially the conservation of energy. That's a very basic principle of physics, that you can neither create nor destroy energy. The second law of thermodynamics is a much more subtle one. What it says is that every time there's an energy transaction, that you lose energy, but you don't sort of lose it in the sense that it vanishes and never to be seen again. What happens is that the energy is degraded in its capacity to do work. It's what we call free energy. So that means that every time any kind of transaction occurs energetically, everything is continually losing energy. This is one of the reasons why the time arrow has to go in the forward direction, because you can't go backwards against the second law. Time is, after all, just events occurring one after the other. I mean, there's trillions of events occurring around you every sort of second of the day. So that the thermodynamic law requires that time goes forward. Also, quantum mechanics plays a role in that, but if we get time, we can talk about that later on. But the thing about this is that everything is tending to wind down. Your hot cup of coffee loses its energy. The way the energy is given off in this case is heat, which gets progressively longer and longer in wavelength. They can do less and less work until, in fact, they can do no work. Now, I suppose I should explain what that means. When you do any kind of work, the energy has to flow downhill. That means to say, and if you like, the work that it does as it flows downhill, a bit like water flowing down a mountainside, is what you recognise as useful energy. That is, doing something. You eat food, for example, to make energy for your body, but a lot of that energy is lost as heat.
Roy will be back with that thought in a moment. Welcome back to Observations. Our guest today is Roy Goodman, speaking from the land down under. We are now discussing many of the issues related to the spontaneous creation of life. We have talked about the fact that there simply was not enough time for the theory to be valid. We've also discussed the probabilities associated with creating even the simplest form of life to the point where it is improbable to the point of being impossible. And now we're talking about, so if the improbable occurred, and it didn't, then what would the natural course of events yield over time, considering the concept of entropy and thermodynamics? And Roy, you were beginning to discuss how all things essentially evolve, but they devolve. They become, they disintegrate. Now, there are examples that we can name of things that have evolved forward. For example, man's weapons of war, from sticks and stones to bows and arrows and spears to guns to the weapons that we deploy today. Boy, we've certainly shown the ability to evolve our weaponry, haven't we?
We certainly have, but of course it takes intelligence to do that.
Well, that, by the way, is arguable. When you're talking about weapons, that's arguable. Okay.
That might be a bad analogy.
Yeah. But look at locomotion. You know, we learned how to ride animals, and then we learned how to tow things behind animals with carts, and then somebody invented a steam engine, and then an internal combustion engine, and we had automobiles. And then someone figured out a way to put wings on it and take advantage of Bernoulli's theory, and we had airplanes. And boy, look how our airplanes have evolved. That's
right. So, but they all required intelligence to do that.
And energy.
There had to be a hands-on individual there who was actually directing the development. So everything that's being done in this industry is that. But of course, it's all fighting against the laws of thermodynamics. So it still requires energy to do so.
Yes.
So if you left it to yourself, the guns would rust, the aircraft would not fly anymore, the cars would rust as well. everything would essentially just disappear down.
So we could say that everything necessary to build a Boeing 747 is available here on Earth, and that and a Boeing 747 is infinitely more simple in its design and in its componentry than is the human body. But that a Boeing 747, everything needed to build it is here on Earth. So if we'd only have enough avalanches and lightning strikes and tidal sway, that ultimately all of those elements would get together in the right order, in the right way, in the right place, and the result would be a Boeing 747. And that once it was there, it would find fuel, and it would find a pilot, and it would fly, and then it would evolve to even a more sophisticated airplane after that. Isn't that macroevolution?
Yeah. That's right. I mean, that's the kind of idiocy that macroevolutionists come up with. That's exactly right. It's the whirlwind in the junkyard analogy, I think, that someone used.
Yeah, but even the whirlwind in the junkyard, the reason I didn't use it here, that's not a fair comparison, because the junkyard is filled with things that intelligent design has made.
That's true. That's true. And keep in mind also that the human body, we don't fully understand the human body anyway. It's even more complex than we thought.
Yeah, our nervous system and our brains is something we have a very limited knowledge of, and even the internal cell biology. And we have been finally able to map DNA, but being able to map DNA and understanding DNA, vast chasms between those things.
Oh yes, listen, you could do a whole show just on DNA alone. Do you want to move on to microevolution, which seems to be the natural progression of things from here?
Sure. So, but just to finish the entropy, the fact is that if life was conceived, it would devolve. It would not progress upwards in gaining information, gaining status. It'd be like the Lloyd's or the Wright's flyer. Given time, would by natural processes become a B-1B bomber.
Yes, but I think what you're getting at here is that if someone of us, for example, devised life in some way,
yes,
that life that would work here on Earth in the current environment, would that life continue on, let alone be able to increase genetically so that it would throw up higher organisms later on down the track. The thing with entropy is that it does not allow that sort of thing to happen.
No.
Generally speaking, I put a caveat on that, because I think that in fact the designer, namely did in fact put in a system so that it could happen, but that was a very subtle way, something that was done that we couldn't do. We could devise an animal, say a combination between a platypus and an echidna or something like that, and it works perfectly well in our environment. But the moment the environment changes and it becomes adverse to this organism, it has no ability to adapt. And the inability to adapt means that it cannot survive. So it would die and disappear.
Yes. For example, gene mutations, which are the explained basis of evolutions, that we have evolved in right in our genetic code. We have gained information, really, and superior arrangements of genes have developed more sophisticated, better adapted creatures. Isn't it true that 99.9%, or maybe even a higher percentage than that, of gene mutations are negative?
Absolutely. The thing that I think that I want to get at is that Yah himself knew these problems would occur.
Yes.
So what he did was he front-loaded the genetic material that he had, so that microevolution, that is, if you like, an upward course, could occur. But you see, again, that's part of intelligence. it's almost as if he were there directing the show all the way along, but he doesn't need to be because of the way that he's manufactured the DNA to begin with. And there's an excellent explanation of that by Mike Jean in his book, The Design Matrix. If you haven't read that, it's certainly worth reading. I think that explains a lot of the problems that we have explaining evolution, because it's quite clear from the fossil record that life forms that were inferior to us, for example, the fossils that were found in the Canadian Rockies were clearly very, very primitive. And yet we've developed up to the point of humanoids, the ape-like creatures, which are far different from that. So there has to be an explanation as to how that came about. And I think the explanation is given very nicely by Mike Jean, which shows that even though that the laws of thermodynamics are working against, obviously or apparently working against this kind of development, it can occur if you front load it into the DNA, so that as challenges come along in the environment, you can get minor variations that will enable not only the creature to survive, but to change very slightly so that it will also develop us at the end.
In other words, our DNA was given a flexibility and an ability to adapt to overcome challenges environmentally, and that was written into the DNA code. So while we look at DNA and we understand what tiny portions of it do, and we don't understand what much of it does, it's apparent that much of it is designed to enable us to cope.
That's right, but there's unfortunately a downside to that as well. If you're going to be doing the random shuffling of genes, it's going to be winners and losers.
Right.
This is, if you like, the cruel bit. There's going to be creatures that do not survive, even though they've done a gene shuffle. It's again, statistics comes into this. If you can pick out the right genes that have been provided by the front-loading process, then you will survive. If you don't, then you will die out. So at the end of the day, we can in fact climb the ladder, but it's only because it's been front-loaded by an intelligent being. And that explains a lot of what we see in the fossil record. But there's another condition called punctuated equilibrium, because evolution didn't give all these billions of what should have been intermediate stages that we could see as evidence in the rocks. And in fact, Darwin was quite aware of that problem. Because that's not there, it would appear as if an organism has suddenly changed from one type to another, almost in the blink of an eye. And they call that punctuated equilibrium. Now that brings us to chaos theory.
By the way, can I just, before we get to chaos theory, when you talk about climbing the ladder, since 99.9% or more gene mutations are negative, counterproductive, what you're talking about is that there are various different types of sparrow bills or beaks based upon the environment that those sparrows live in, and that there are different adaptations among monkeys depending on the kind of trees that proliferate their environment. That within certain species there are adaptations to the environment. But when you're talking about the difference between a fish and an elephant, we're not talking about that kind of up the ladder. We're talking about very fine tuning of animals over long periods of time to cope with their environment.
Yes, you can fine tune it. See, Mike Jean pointed out in his book that there are a number of enzymes that occur in single cell bacteria, organisms, that are not required because they are used exclusively in multicellular organisms. Now, evolution, in fact, to make an enzyme is an energetic process. That means that the cell is at a disadvantage to do so. So to make that enzyme, that means it's more likely that the cell will not survive. So why put it in there in the first place? And if it was front-loaded into it, it's designed so that when conditions are appropriate, those genes can be expressed. That is to say, the cell joins together with other cells to make multicellular animals. Otherwise, you've got a problem. For example, why don't we see monkeys in the ancient rocks?
Yeah.
Why don't we see them? We don't see them because they're not there. I don't think it's simply that we've just missed out on seeing them. I don't think they were ever there. I think that there has to be some explanation for what we do know to be true, and this is one of the reasons why so many people hold evolution to be true. It appears, at least on the face of it, that in fact we have climbed the ladder. But I'm saying that we've climbed the ladder because of intelligent front-loading or intelligent design, so that it's possible to do that. But there is a lot of wastage along the way, in that organisms that have these deleterious mutations will die out.
And what we don't see is a paper trail of all of that. And if it was simply adaptation to one's environment and simple life forms continuously becoming more sophisticated, then the paper trail, the evidence of the fossil records, should be ubiquitous, but it's not.
That's right. That's right. And this is where chaos comes in. Chaos is a relatively recent theory that's been developed. We see chaos all around us. The weather is a classic example of it. The flow of water in a stream, the stock market, human behaviour, whatever. If you look closely, you can see chaos all around us. Now, one of the things about chaos is that, I'll give you an example of water flowing down a stream. And you might be going over rapids, and it's extremely rough. You can't really tell what's going on. There's water here, there's water everywhere, it's jumping up and down, it's going around in circles. And every so often, you'll find that there'll be a single place, somewhere in all of that, where it suddenly becomes still. And you can't explain why, it just simply becomes still. And then, as the parameters change again, that stillness disappears and continues on. So I suspect, and I can't prove this, but I suspect that chaos with these islands of stability, as they're called, in chaos, is what has enabled the evolutionary climb, if you like, up the ladder. That is to say that organisms can find themselves in a stable environment where they can, in fact, adapt and thrive, and then when the chaotic system again asserts itself and the environment becomes chaotic again, they will die out, with the exception of a few individuals who, by virtue of their gene shuffling, have managed to survive. Now, I know that sounds a little bit tenuous and a bit of a dodgy theory, but I can't explain in any other way how we could have come about unless there was an intervention all the way along to produce the animals that we see. Even just recently, for example, in the tar pits of Abrea, for example, all the Abrea,
yes.
You know, these creatures that have become extinct there.
Right.
Those, were they created, or did they simply evolve from other animals? I know you can say that a lot of them would be variations on the theme, and indeed they probably were. But if you go back further, you don't even have to go back to the extinction of the dinosaurs. In fact, the dinosaurs themselves are a problem. I mean, yes. where do they come from, and how could they have developed in any other way? Unless there's two explanations. One of them is they evolved with front-loaded evolution, or two, Yah created them as he went along.
As a matter of fact, the dinosaur, or the mighty lizard, which is what dinosaur means in Greek, mighty reptile, is a term that Yahweh specifically uses amongst the things that he said that he created. And then once he created these various things, he allowed them to evolve within their species. It seems to be the only rational explanation for what we are witnessing, particularly in the fossil record, since we don't have intermediary species and we don't have hundreds of billions of failures, which would have been the result. For every successful creature, you'd have to see the remnants of 100 times that number of failures, and we don't see them.
That's true, but if you had islands of stability in chaos, for example, you would have creatures that were almost identical. Most of them would then be wiped out. That's an extinction event.
Right.
That's also an extinction event because of genetic deterioration. But in one or two of those one or two of those creatures, there may have been a mutation that was, in fact, beneficial. It may have even been pre-programmed. So then what you've done is you've gone from a large population of identical creatures which you can identify on the rocks, and a sudden jump to another kind of creature. Now, it wouldn't be necessarily a big jump, because I don't think it would be biologically possible, but it would be a jump that would be sufficient to distinguish the two from one another. Otherwise, you come back to Yah being a hands-on creator.
Yes.
I don't think there's any other explanation that you can come up with.
No.
And I think Mike Jean's explanations in his book are very, very compelling.
Yeah, exactly. I'm going to have to leave this segment at this point. I want you and Scott to continue the segment, but I know you have a lot more to cover. One thing I make sure that you do cover in the time that's remaining is this realization that you can use these same kinds of thought processes to go through the predictive testimony of Yahweh to determine whether or not he can be known and whether or not he can be trusted, and whether or not God designed the system that we are talking about in such a way that he wants us to think about it and try to understand it, because it's the same process by which we come to know and understand him.
Yes. And I just want to apologize to everybody listening now, because there's a huge drop-off from Craig to me.
Okay, I'm sorry. We may have an internet-related issue. But anyway, Scott, I do need to part at this point. Why don't you and Roy carry on?
We will.
My pleasure being with you.
And
we'll continue on another day, Roy.
Okay, we'll do.
Okay. We'll talk to you next time, Craig.
Okay, bye.
Bye-bye.
Where do you want to go from here, Roy?
Well, after that one, that actually brought up some doubts in my mind as to the validity of what I've been saying.
Okay.
I don't know how much you know about biology. It might be best if I just simply read out what I've already done.
Yeah.
And
I have what you wrote right in front of me, so I can kind of follow along, and I'll chime in with you here.
Craig puts it much better than I do, but so I think I'll, since I'm only a beginner at this sort of thing, I'll just continue with what I've said. I said the microevolution now is see, how would a designer design life with all the uncertainties that go with an unpredictable universe, and that's what we're just talking about, and not be on hand at all times to keep life going when it meets an insurmountable hurdle. Clearly the ability to survive, prosper and to adapt to adverse circumstances must be built into the design of life from the beginning. A species of animal or plant that could not adapt would not be able to reproduce and would simply die out. And the problem with that concept is, as Craig touched on, is that there is no paper trail. There isn't a series of animal type 1 going to animal type 2 going to animal type 3 in the system. So that has to be explained in some other way. I don't know whether you're familiar with the fossils that have been found in the Canadian Rockies. They were found at about the time of the Cambrian explosion, and they were very, very simple organisms. Now, we've got organisms that have changed over a period of time, going through the Devonian period, which is called the time of fishes. Then into the Carboniferous, which is when there was lots of trees and things around. Then we got into the Silurian and ended up with the Cretaceous period when the dinosaurs were, and then we got into the Mammalian period after that when the mammals appeared. So did Yah intervene each time to make a new type of species? It's possible. Are we told that? I don't know. I can't think of anything in Scripture that tells us that would be so. You might be able to help out there, or maybe one of the others might be able to.
Yeah, on that part, I don't really have anything to add to that. Larry would be the one that I think might have something to say there.
If he's listening and can ring in, that would be appreciated. Because my strength is more in science rather than in Scripture.
Well, let's stick to the science then. Let's continue on with the stuff that you had written.
Okay. All right, well, I'll continue. So immediately we have one of the design features for life, sexual reproduction. It is true that some organisms reproduce by parthenogenesis, that is non-sexual reproduction, but the vast majority of living creatures use sex. The reason for this is to defeat the effects of quantum uncertainty in its handmaidens, chaos and thermodynamics. The genes Yah has provided can be shuffled, cut and rejoined as they are during sexual reproduction, so that out of all the individuals alive, some will have the ability to overcome an existential challenge taking those individuals into the future with a slightly different genetic makeup. In this sense, Dawkins was nearly right, but instead of a blind Mother Nature randomly doing the gene shuffling, the genes were initially set up by the Creator to allow just that survival mechanism to happen, which is what I've just been saying with Craig. Atheists such as Dawkins, of course, contend that there was no designer, that the natural laws of the universe would combine to cause evolution to go onwards and upwards to better things all by themselves, using only natural selection as the designer. His book, Climbing Mount Improbable, was premised on this description with the addition of eons of time. Mutations of the genetic code is at the root of the small changes proposed by Dawkins and others as the basis for microevolution. Now, microevolution follows on from, of course, macroevolution, and that is essentially once the genes have been created by Yah at the time of the Cambrian explosion, he just lets the system run, and we have microevolution, which changes organisms in adaptation to the environment. So it's a front-loaded, intelligent design. So those ideas I have dealt with in my paper, and I won't repeat them in detail here. Safe to say that despite the popular view that all mutations have a beneficial effect, it has been shown by Behe and Sanford and others that this is not so. Beneficial mutations are extremely rare and are beneficial not by improving the genome, but by a loss of information conferring a survival advantage. And a classic example of that is sickle cell anemia, in which there's a mutation in the DNA that causes an abnormal protein to form in the red blood cells in people, and they form into the shape of a sickle. Now, for reasons that I don't know, the malarial organism doesn't like that kind of cell, so these people are more or less immune to malaria. But the thing is that there's still an information loss when this happens. That is, the DNA has been degraded down through the thermodynamic curve. So continuing on, however, there's an element of truth to Dawkins' ideas. We know just by looking around that species do change in response to the environment. We do know that natural selection occurs with the extinction of some species because of natural changes or predations of mankind. So in addition to sexual reproduction, is there another way to design life so that it will adapt to changes in the environment, be self-sustaining and be self-reproducing? Mike Jr. in his book, The Design Matrix Proposal, I think is the remainder of the pieces of the puzzle as to how life can be created and at the same time evolve. His idea was that evolution was front-loaded into the genome when it was created for the Cambrian explosion, so that eventually all the forms of life that we have today would occur without further intervention on the part of the Creator. And this again is, I think, where the difficulties come in with what we're discussing. This front-loading is in addition to the gene shuffling of sexual reproduction and relies on the chemistry the Creator chose to build into our ancestors' bodies, so that genes that code for one biochemical pathway may have hidden in them code for other protein structures that would give a survival advantage to organisms that express them at the right time. Many examples of co-option, gene duplication and other methods by which front-loading could be made to work you will find in Gene's book, which I recommended reading. As mentioned before, we live in an island of stability and a sea of chaos. This stability, combined with the Nisama Yah has given us, has allowed us to advance very quickly technologically. In past eons, these islands of stability and chaos would also have been present, but could not have been exploited as we have done. Nevertheless, a stable environment would have permitted a species to increase in numbers rapidly before most succumb to a serious adverse event marking the return to chaos. Such an event could have been an extinction event based upon deterioration of the genome within the species. Sanford, in his book Genetic Entropy and the Mystery of the Genome, explains this very well. Within that species, a few individuals would have changed genetically so that they had the ability to survive and continue life as a slightly different species when the next island of stability came along. How would such a form of evolution sharpen the rocks? It's more or less as we see it. There are no Darwinian intermediates, just a series of jumps in the fossil record, punctuated equilibrium if you prefer. Interestingly, from the above discussion, it is clear that if evolution was run again, the actual trajectory would be different, but the outcome would be the same. That is, the desired end product of humanoids would eventually occur, even though the Creator himself could not a priori predict the path that evolution would take. Stepping back to look at the overall picture of Yah's creation, we see on Earth that formed 4.5 billion years ago. It was bombarded by comets, and we're melting its crust until it cooled to support life 3.8 billion years ago. Then Yah created a genetic code that first produced archaebacteria, and over the next 3 billion years or so cleared the atmosphere to be the clear blue sky we see today, where the sun and the moon are clearly visible. Then over a period of about 5 billion years from our point of view, or 2.6 minutes from Yah's point of view, Yah either modified the genetic code or made a new code at the Cambrian explosion, at which time all the phyla that now exists sprang into existence. From then on, life evolved in a somewhat pre-programmed manner until the time of Adam and Chava. From there, as they say, the rest is history.
We actually have Frank called in and is talking. He's here. Frank, can you hear us?
Hello, Frank.
Hi, Roy. How you doing?
Hello, Frank.
There, I got the mic from the big speaker out of the way. How you doing, Roy?
Frank, can you hear Roy, Frank?
I lost you. Yeah.
Okay.
I'm back now.
There we go. And Roy, you got him?
Hi, Roy.
Yes, I've got you. How are you, Frank?
Good. Hey, enjoying every minute of the conversation.
Yeah, what did you think about that last segment?
Actually, I think I was letting Diane out of the car right at the moment, and I actually didn't hear the last that you said. So you better bring me up to speed fast.
Well, I think where there's a potential problem that really hasn't been satisfactorily addressed is that Yah has created the genome at the time of the, or modified the genome at the time of the Cambrian explosion. From then on, we need to know what's happened. It's quite clear from the fossils in the rocks that there isn't a series of intermediates. It would have to be an enormous series of intermediates to show that Darwinian evolution was right. Since that doesn't happen, then we can assume that something else must have happened, such as punctuated equilibrium, which is another version of it. Now, punctuated equilibrium in evolution could be explained in terms of chaos theory, but that's getting pretty complicated. The problem that I think that we do have is that, as Craig was saying, I mean, monkeys will change adapt to their environment by changing their form, but they still remain monkeys. The problem is that we don't have monkeys in fossils in the rocks going back to the Cambrian times.
Right.
So that means that must mean then that do I stop here?
Yeah, we'll stop here quick. Hold that thought right there, and we'll be right back.
Hang on, we'll let it go through the break.
Yep. Welcome back to Observations. We're with Roy and Frank. And Roy, if you could continue on with your microevolution talk.
Certainly will. Frank, I understand that you didn't hear very much of what I'd said beforehand. So the problem that I think that we have at the moment is that the front-loaded design is very compelling. That is to say that Yah had put into the genetic code right from the very beginning, either at the point when the Earth was just cool enough to support life, or at the Cambrian explosion when the 30-odd phyla that were present came into existence. The problem that we have is that there's no continuous species change in the rocks to be found, evolution from the geological point of view. That is to say, you can't go from organism A to organism B through a very small change to organism C to a small change and so forth, all the way up to us, even though it is possible to front-load the DNA using sexual reproduction and the actual chemistry of the DNA to be able to do that, to defeat the effects of thermodynamics. But you also require chaos to do that. The problem that we have in the rocks is that we don't have any kind of evidence, for example, that there's monkeys were down at the time of the Cambrian explosion. That means that either front-loaded evolution is true, that is to say that in fact somehow or another the evolutionary process continued from the time of the Cambrian explosion upwards, apparently against the laws of thermodynamics, to produce us as humans, or Yah intervened along the way to redirect evolution or recreate, if you like, organisms such that eventually we would be thrown up as well. We do know that humans have been around for thousands, hundreds of thousands of years, long before Adam was given the neshama. But I think there's a fundamental problem here in that we can't resolve the absence of the sequence of events that should have occurred versus what we actually see, even explained by what are called jumps in chaos, from islands of stability to chaos and back to islands of stability.
Well, Roy, don't we actually see that in the record when we see that there was no man with Nasama, even though we can't show that he's different than humanoid in a skeletal record, but we actually show that Yah intervened at a point and created mankind with Nasama as opposed to mankind without.
Well, that's true, but did he create the mankind without, or did we just simply evolve from apes? That is the ultimate question, I think. The point I'm trying to make is that Mike Jean's ideas of front-loading evolution explains a lot of what we see, but not all of it.
Right.
And I think Craig has touched on that point there. There's no continuous series of changes in the rocks that would be demanded, or I should expect to see if in fact that form of evolution did occur. The only exception to that would be something that really is a hypothesis of mine, and I've not seen it expressed anywhere else, but if you've ever seen what excuse me, chaos theory does, it explains why you can have a chaotic event, and I used the example of a stream, flowing over rocks. And if you have a look at that, every so often in that stream, maybe even moving along with the stream, there's an area of stillness in it. It's an area of where everything that's going around it doesn't seem to affect it. And I think that if you extrapolate that then into genetics, that you have an area of gene stability apparently against the laws of thermodynamics, and then that gene stability slowly erodes with the laws of thermodynamics until that organism goes extinct. The problem then is how do you get another one to come along that is materially different? That is to say that you don't have a series of little jumps between them.
Right.
That I think is a fundamental issue, and I think Craig has illustrated that quite well today. But he's also got a problem that if Yah created the system right back at the beginning of the Cambrian period, why don't we see fossils of monkeys, for example, or elephants, or horses, whatever? We just don't see them in rocks of that age. So there has to be some explanation for what we're seeing. And all I can say is I suspect that in fact it's a combination of front-loading of the DNA, of the genome, combined with islands of stability and chaos.
Is it possible that Yah, being the creative genius that he is, as he's seeing the evolution of Earth and all of the creatures and plants and so on and so forth, that sees that there's a need for different types that could be created for man at a different phase in time of creation, as opposed to would give an example of why they weren't showing in the early fossil record.
Well, no. I'm not quite sure what you're meaning by that. Can you explain that?
I'm not sure if I know. I was saying that is it possible that Yah created other species like what he did in creating mankind with Nasama sporadically somewhere during the evolution that we're talking about? Like you were saying, there weren't forces showing earlier, is it not possible that Yah intervened to create horses?
Well, yes, this is what I'm saying. And there's only two explanations for what we know to be true. What we know to be true is found in the rocks. We know that the age of the rocks by nuclear chemical analysis, for example, plus the fact that stratigraphy, get that right, that is to say that the way that the rocks are laid down. Certainly there has been some confusion about that, but the Burgess Shales, for example, would be an example of a very ancient seafloor in which these organisms were floating. The Canadian Rockies got pushed up, the mudstone that made the seafloor was then compressed into rock, and along came buggerlugs and broke a rock open and found the fossils there. But none of the fossils contained anything more advanced than what was thought to be present. Now, that's sure, it's only a little tiny window on what was possible. There may have been other things there, but no one has ever found anything that gives evidence of a higher form of life. But we do find, as you advance through the rocks, you find the characteristic change. I mean, if you just read a textbook on geology, it's easy to see what's going on. If you go through the rock strata, you'll find that primitive forms of dinosaurs appeared, that you'll find that dinosaurs that flew appeared, you'll find that dinosaurs that had big munchy teeth, like T-Rex, for example, the kids' favourite, appeared. Then you'll find that they all disappeared. And then the next thing you see is little shrew-like animals, which are mammals, which may have and probably did coexist with the dinosaurs, but were not visible. And then these grew up into your horses and elephants and cows and eventually up to man. This makes sense. I somehow suspect that this is true. The only problem that we have is that there's no geological evidence for it. So if there's no geological evidence for it, that leaves you only two possibilities: punctuated equilibrium caused by chaos, or Yah himself intervened from time to time to actually direct the evolution.
So what you're saying is that at this point in time, there's no evidence in the rock showing that. Is there any chance that we just haven't seen that, or that we have discovered enough that we know that there just isn't any record?
Well, there's always a possibility that you've missed a lot of stuff, but I mean, you would have to have missed a hell of a lot of stuff, considering every possible creature that would have ever evolved or been created.
Right.
I mean, I really don't believe that would be true.
All right.
Does that make sense?
All right.
So that I think is one point that really Craig put his finger on that is of some significance there. I intuitively believe that what Mike Jean said is true. It's just that demonstrating it is going to be very difficult.
Right. Well, we can always get Craig back and have more discussion on this point at a later date also.
Yeah. Does what I'm saying make sense to you?
Yes. Yes.
Yeah, it makes sense.
Macroevolution is definitely impossible. We've proved that. That's just simply a non-starter. So if macroevolution is not possible, life exists on Earth as we have it today. That means that it's either developed spontaneously from nothing, which is macroevolution again, so that's not possible. Therefore, it had to be created. So it was either created here on Earth or it was created somewhere in space. If it was created in space, that's Fred Hoyle's panspermia hypothesis. It could have been brought to Earth. That's if it was created by a creator in space, that's a sort of a remote possibility. The only question is, I'd ask, why do that? I think. Go ahead.
Well, when you take every species and the uniqueness of it, the DNA of it, and all of the makeup of it, and how uniquely it's made, the chances of that happening randomly are
impossible.
Right. It's basically impossible.
It's in fact, as we discussed, Fred Hoyle himself did the calculation, and the probability of making even the simplest bacterium was 1 chance in 10 to the 40,000. That means 10 multiplied by itself 40,000 times. It's just impossible. It's vanishingly small. It's just impossible for that to have occurred. I don't think there's any issue with regard to macroevolution as to what's happened. The issue comes into microevolution as to whether Yah managed the evolutionary process step by step along the way. That could account for punctuated equilibrium, or if he just simply front-loaded the DNA so that all the creatures that we see would climb up the ladder, from very simple organisms like these strange things in the Burgess Shale, up through dinosaurs and all the mammals that have occurred, the prehistoric horses and mammoths and things like that, which are probably just really elephants that just adapted here, eventually to man. So those are the only two possible solutions. Yah stepped in from time to time along the way to direct the evolution in the way he wanted it, or he allowed it to run by itself from the beginning without that.
Right. I like the part of your theory where he's walking with me, talking with me, and helping me every day, just because I need help.
Well, that's right. And that may in fact be that he did in fact walk with the animals. He did in fact create them over a period of time.
Right.
That is to say, he intervened regularly to make sure that the evolution went in a particular way.
Right.
Then again, from his point of view, the Cambrian explosion only occurred over a period of 2.6 minutes, whereas for us it was 5 million years. So that means from his point of view, the rest of the time would have been fairly short. In fact, the day of creation from the time of archaebacteria to the Cambrian explosion was about day 4. Day 5 would have taken it up to the time of either the creation or the manipulation, shall I put it, of Adam's genes. So that's day 5. So we have essentially microevolution is then compressed into day 5, and then day 6 is the time of man, when, if you like, 6,000 years. So the time between the first day is a lot longer than the time between the second day, the third day, and so forth. So that we end up eventually compressing time down to just 6,000 years for the time of man.
Mm-hmm.
So I mean, all of this is consistent with what we see in Scripture. The only problem that I'm having is how did we get from the Cambrian explosion to mankind with animal intermediates that we know existed and no longer exist, as well as the sophistication that we see now that we didn't see back in the time of the Cambrian explosion, at the time of the Burgess fossils. Burgess shales, they're called. That I think is the issue, and I suspect that Yah was not hands-on in day 5. After all, that was Satan's time, wasn't it?
I didn't get it. You said you suspect he is hands-on?
I don't suspect he was hands-on, but that's only my speculation. I don't know.
Right.
Those are the only two possibilities when you boil it down.
Right.
Otherwise you have to explain the absence of higher order fossils, for example, in very ancient rocks, and you can't do that.
Right.
So that means he had to intervene along the way, or he pre-programmed it so that it would go the way that I suspect he pre-programmed it because he wanted to give us free will. To give us free will, we must have had a universe that was indeterminate. That is to say that not even he could see the end from the beginning. He could, because his ability to see our time in the future, could see how it happened, but he wouldn't have the ability if he was just sort of sitting back at the very beginning to see exactly how it would work out. That's where quantum mechanics, thermodynamics, and chaos all combine, if you like, to make it impossible to predict what is going to happen in the future. Certainly from our point of view, this is why we can never see the future. Because these sort of things take that ability away from us, but it also takes it away from him. And that's probably the way that he would want it, I think. there's no point in just having someone to explore the universe if you've already done the exploration. It's no fun sort of coming across an interesting scene or something that you wouldn't have expected to happen.
All right.
By yourself or even with somebody if you already knew that it was what was there. So I think to make eternity fun and exciting, this has to be the case. It also has to be the case, incidentally, in his domain, if you think about that as well. That is to say, when whatever dimension he exists, he cannot see his future. He can see our future in his past, because he's so much more energy, so much more mass, if you like. His time slows relative to us so much that we're sort of leaping ahead of him, so that he can then see what happens. But he can't see in his dimension what his future is going to be. So Yao is restricted in many things that he can and can't do. He can't be illogical or irrational and have a universe, for example, that is logical and rational. I know this sounds a bit strange to most people's ears, but I think if you think about it, that's the only outcome that it can be.
So do you see another program that you would like to do to take some time to do some more research of this and be back on with Craig, that he can, the way he connects the dots and all, to help bring some more clarification to this?
Yeah, that would be a good idea, but I'm not quite sure how I'm going to get any more information concerning geology and paleontology. Paleontology is simply the study in the rocks of the ancient animals.
Right.
It's really a paleontological problem.
So we can talk with Craig and see if we could set that up to go on, to go back and try to cover that area. Is there any other areas that you wanted to cover today that moved on past this point? Some information that you wanted to make sure that you got out about this?
Yeah, well, what I can do is I've written, so I've copied a part of the original document that I made, and I've pasted it onto the end of this talk that I've given here. If I may, I can read that out. Have you got time to do that, Scott?
Yeah, we got time, definitely.
Okay.
I'm loving what you're saying, so yeah, continue.
Incidentally, does what I say make sense?
It does. Yeah, it makes sense. I mean, what you're saying, it's not beyond my comprehension of what you're saying. Some of it's like when I deal with Craig. Some of the connections you're making, they make sense, but I'm just not making the same connection at the same moment. So I'm still trying to take the data you're giving me now and turn it around in my head. So and this is the whole reason I wanted Craig here to begin with, because just the way his mind works, it's definitely a beautiful thing. And I'm a person that I hear something and it sits in my brain for sometimes days before I finally can come up with something to say about it. So
I'm like you, Scott. Oh, that's what that meant.
Yeah, I mean, it could even be like 5 hours from now. I'll be sitting at home and I'll all of a sudden, oh, wait a minute, that's what, listen, that makes way more sense now. And so, and it was the whole reason why I wanted Craig to be here. He's the way his brain fires, it works out well for this. And the way, I mean, listening to you two talk was awesome for me. So, by all means, continue on with what you're going to say.
I'd like to know what his IQ is. It's certainly way above mine.
Well,
I've just got all this information because I've taken the trouble to get it. Otherwise, I'm just like any other ordinary individual. I think Craig thinks in a way that's very different from me. I think in a way that's very different from most other people too, but I think he's way above me in the speed with which he can put sensible concepts together.
It's how quickly he connects the dots.
How quickly he can do it, yes.
We agree.
Anyway, I'll just finish off with this, if I may. Said, you, the reader, are near the end of my short overview of the evolution of life on Earth. Questions such as what is life, what is a soul, have not been addressed, as they are not directly related to the physical development of life according to the parameters set by the theory of evolution. We have simply assumed that something called life exists as distinct from inanimate objects. The very word inanimate gives a clue, not animated, not able to respond to the environment. Is life then simply the right ordering of molecules and atoms such as a creature, that a creature existed is able to respond to the environment? If we look at the analogy of a computer, that appears on the surface to be true. Ignoring how the computer came into being for the moment, we know there is an additional component that allows it to interact in a limited way with the environment, that is software. I say limited because our programs are still primitive. Software animates the computer. Software is not physical. If you added a program to a computer, you could not detect even the slightest change in mass. In religious terms, you could call the software a soul. Incidentally, Frank, that's what we were discussing, I think, last Friday. Nefesh and the Sama.
Okay.
Note that the software did not appear spontaneously in our example of a computer, so could software evolve? At the molecular level of life, that is clearly impossible. Molecules simply interact according to the laws of physics and chemistry. At a higher level of organisation, we know, for example, that an amoeba will move away from an unpleasant stimulus or towards a pleasant one, such as food. As we have demonstrated that Yah created most primitive life, he doubtless included programs of animation. Logically then, since microevolution is front-loaded and there is no further input from the creator, this is where the problem occurs, of course, then the ability to evolve a soul for all forms of life must have been front-loaded as well. Even some plants have very primitive avoidance mechanisms, though we don't have triffids yet. Thus the physical microevolution and the metaphysical microevolution must have gone hand in hand. Primitive man eventually evolved with a sophisticated program, which in Hebrew is called a nefesh. In computer terminology, this is an operating system. In man, a very advanced and sophisticated system is still only an operating system. To get past the point of responding only to the basic needs of food, shelter, sex and survival, primitive man needed something else. He needed, in Hebrew, the neshama, which in computer terms is a plug-in, or if you like, another program. The neshama was first given to Adam, and from him the rest of humanity. This gave us the ability to think abstractly, to form concepts without apparent benefit and beyond the basic needs. It gave us the ability to wonder about the woods and trees around us without seeing them only as a source of danger or food. We could wonder at the sun, moon and stars and think about how they got there. We could think of a creator for everything we see, hear and feel. It gave the ability to detect the difference between right and wrong, good and evil, and it gave the ability to choose between them. It gave free will. Within the Shama, we are still animals, but with the ability to raise ourselves above the beast and to interact with the Creator. And the Shama then would have been transmitted in the same way a Nefesh is transmitted after Yah gave them the Shama to Adam and Chava. So when they were ejected from the garden, they mated with the surrounding men and women, transmitting the Shama down through their generations. To do this, the Nasama gene would have to have been dominant. The ability to think and plan ahead that the Nasama gave these people meant that they could and did wipe out their human rivals, both with the Nasama and without. So then we came to the time of Noah. Evolution by definition is a brutal process. Life for most is short, brutal and over quickly. So why did Yah create the universe in this way? I believe he did because to carry out his purpose he had to. Muslims believe their God, that is Satan, is unlimited in anything he can do. His will is arbitrary and fickle. For them he can make black white, 2 + 2 = 5. Such a God would be the very definition of chaos. Even the process of thinking or logical thought could not occur because in our world we rely on the laws of physics to remain constant and unchanging. The real God is in fact constrained by parameters that could be called universal. Logic and reason must be universal parameters for order to exist. Likewise, 2 + 2 must always equal 4, not a round 4, not a fuzzy 4, just 4. If Yah wanted to reproduce himself by having a family, how would he do it? The duality of order and disorder are universal. God is a God of order. If he wants an ordered family, he could just create a clone of himself and get a family that way, but that would be like addressing yourself in a mirror. Your other self always answers back in the same way you would, and you know exactly how, even before the other self has opened its mouth, and is to all intents and purposes identical in thought, actions and appearance. That is clearly pointless. You might as well stay alone as have an echo chamber of your own thoughts. In a way it might be another form of hell. So being slightly different from you to be interesting, but with desire for order, must be created. But how? By creating a being with your ability to use logic and reason that has the knowledge of order and disorder, and make a choice between them. I have a few sentences I'll leave out which aren't relevant. Those who have an inquiring mind, imagination, enjoy discovery, have the geography and genes implying a family background that allows an open mind, and are willing to invest time to seek out a creator, will do so as they will come to know there must be one. His name is Yahweh, and his means of communication is the Torah. Those without the above characteristics will not and will be discarded. They may have a pleasant but limited life, and after that they and their nefesh are no more. And for that I've quoted Mizmor's Psalms 1, 4, 5, 5 to 6 and 103. Those with the correct characteristics are who Yah is looking for. They are like but slightly different from him, able to think and act independently, yet enjoying order all the time. So in this sense, microevolution is a sieve filtering out the gold from the dross. He knows his family members and will act to protect each one. He doesn't know the rest because they do not know or want to know him. Would you act to protect the family of someone hostile to you, someone who may be a member of Satan's family, for example, when you have your own family to protect? The dross is discarded, yet the dross, that is thinking humans but with the wrong way of thinking, would of course like to live forever in the way they think is best. Who wouldn't? So when Yah appeared in diminished form as Yahusha, he selected those with the right way of thinking and at the same time spoke to the others in such a way that they could not be saved, as they did not understand who he was, and certainly did not and could not know him. That is Mattaniah 13:15 and Yahuchanan 12:40. Much of the above is speculation on my part and therefore could be wrong. Yada, the author of Yada Yahweh, an introduction to God and questioning Paul, has made specific predictions based upon the Torah, prophets and Psalms. If you, the reader, decide not to accept some or all of what he and all those who have contributed to the understanding of Yah's word have written, that's okay. That's your choice. You may recall that in the section on self-organisation, I castigated those who put forward scientific hypotheses that could never be tested. Such ideas are science fiction, not science. However, what we have written is a testable hypothesis. Not directly, but indirectly. You have to wait no longer than October 2033 to see if we are correct. If we are, Yahusha will return and any arguments about evolution, physical or metaphysical, will be moot. If we are wrong, then life will continue until we all die in a nuclear conflagration or we die naturally, after which we will know nothing, and of course not care whether you think we're nuts or not. Either way, there's only 18 years to go from the time this was written. Before then, I believe you will see signs along the way that should make you think. And there's one final thought. As a theory, macroevolution is one of the adversary's greatest triumphs. It gives those who hate Yah an intellectual basis for their belief in the religion of man and a convincing story to mislead children and students, leading them away from the greatest gift they could receive. For indeed, superficially and even at a deeper level, the theory is enticing. It is only when examined at the molecular level that it falls apart and its satanic origins become visible to those with eyes to see.
Do you have a place where people can find what you wrote? I know you sent me a copy of it, and I've been following along as you've been reading it.
It's on Frank's site.
On Frank's site? Okay. And Frank, what?
That's correct, isn't it?
You can actually find it on www.poweronhigh.com, and on the left-hand navigational side at the bottom, you'll see it says Woast Post. That's W-O-A-S-T, capital P-O-A-S-T, Woast Post, and that is a place where users can post documents, and they'll find Roy's full evolution document there, as well as the one from today's broadcast. And so that's the place you can find it.
Well, we got about 30 seconds here. Roy, thank you for coming on and sharing. Frank, thanks for stepping in and helping me out here, because again, I'm sitting here, I'm still kind of trying to process things. We'll get Craig back on with you, Roy, next time.
Did you have any questions about the last bit that I read out? Anything that was obviously that you wanted to ask questions about, or that you thought might not be right?
Not at the moment.
Okay. If you do, let me know, and I'll see if I can address them. But thank you for giving me the opportunity to talk today. It's certainly been very revealing for me.